As you know, your passkeys need somewhere to live. In the previous video, we implemented the user repository, but without a dedicated JPA repository for our passkeys, we are going nowhere. So in this one, we will create the JPA User Credential Repository, which is responsible for storing, retrieving, and managing passkeys in our database. Let's get started. We start by creating a new class called JPAUserCredentialRepository. Our class will implement User Credential Repository Interface. And as before, we have to implement 4 methods. We will annotate our class with the @repository annotation and required args constructor annotation. We need to access both user and user passkeys entities, so we will inject user repository and user passkeys repository using the constructor injection. Starting with the delete method, we are receiving a credential ID of type bytes. So we will create a method inside the user passkey repository that returns an optional of user passkey with the function name findByCredentialID, taking string credential ID as a parameter. Back in our implementation class, let's call user passkey repository.findByCredentialID, passing in credential ID to base 64 URL string. Then if it's present, we trigger user passkey repository.delete. Moving to the save method, we will also call user passkey repository.findByCredentialID, passing in the credential ID as a string. Using the if present or else, we can handle both creating a new passkey or updating an existing one. We reference the existing user passkey, otherwise for now, we will declare an empty arrow function. We start by setting user passkey.setSignatureCount equal to SignatureRecord.getSignatureCount. Our second variable is setLastUsedDate, and we get it from CredentialRecord.getLastUsed. For setAttestationObject, we call CredentialRecord.getAttestationObject.getBytes. We can also update the booleans for backup eligible and backup state. Let's also update the UV initialized in case it got updated for any reason. Finally, we call user passkey repository.save, passing in the user passkey. Now, moving on to the else part, for creating a new passkey, we start by declaring a new passkey variable and let's call it passkey. Then assign it from a new passkey. Feel free to create a builder instead, but for now, I will be using the setters. I will start by setting the credential ID from CredentialRecord.getCredentialID.toBase64 URL string. We can bring the fields from the update part since they are the same. Then we set the label using CredentialRecord.getLabel. For set credential type, we fetch it from the CredentialRecord.getCredentialType.getValue. For the public key, we will use base64.getURLencoder.encode to string and pass in the CredentialRecord.getPublicKey.getBytes. Next, we will set the transporters. As mentioned before, we are converting this set to a comma-delimited string. One way to achieve that is by using .stream, then mapping authenticatorTransport.getValue. We need to call .collect with collectors.joining and using comma as a delimiter. Next on our list is the set created date, and we need to use the value from the credential record. Don't try to set it from instant.now. Then we need to call user passkey repository.save, passing in the user passkey. Not sure if you noticed, but I missed setting the user, which is the most important part. But in a few minutes, you will see why I skipped that. First, we need to fetch the user by declaring a user variable and assign it to user repository.findByExternalID, passing in the credential record.getUserEntity and converting it to string using the base64 URL string method. Then we simply call user passkey.setUser, passing in the user entity. Moving to the third method, we return user passkey .find by credential ID using the credential ID parameter. Then we need to map the entity to the proper return type. Checking the credential record interface, it has a single implementation, the immutable credential record, which has a private constructor and a builder. Back in the map function, we call immutable credential record.builder.build, or else we return null. For the mapping, we will take the values from our entity and map them to the credential record. The only thing we will be converting is the transports field back from a comma-separated string to a set. Other than that, nothing special here. We should extract this mapping into a separated method, since we need to reuse it in the upcoming function. We will call the method toCredentialRecord and move it to the end of the class. We could also replace the mapping with a lambda, and that's it. For the final method, we need to create a new method under the user passkey repository that returns a new list of user passkey, and we can call it find by user external ID, which takes in string user external ID. Using query annotation, we select alias u from user passkey where u.user.externalID is equal to our parameter. Back in the implementation, we return user passkey repository.find by user external ID using the user ID. Then we call .map and reuse our mapping function. And finally, we will convert the result to a list. With that, our implementation is ready. We can run the server. I will connect to the local database by creating a new data source using localhost and root for both username and password. For database field, we enter the database name Passwordless. After we finish, we will see that Hibernate automatically generated our tables. Let's navigate to the browser and access localhost 8080. We are redirected to login page just as before. We use admin and 1234 to log in. We currently don't have any devices registered, so we will try to register our Chrome browser as an authenticator. We hit continue and use fingerprint for verification, and we hit an error. So if you didn't expect that, you should really check my Udemy course, Spring Transactions in Depth, for a deep, practical understanding on how transactions work, where we build a real-world application step by step. Back in the IDE, in the console, we see a well-known error, no session exception. Navigating to the JPAUserCredentialRepository, we will annotate both methods with transactional, with a read-only attribute, and set it to true. Back to the browser, we will log in, and now we have the Chrome passkey added. We will also try to register our mobile as an authenticator. We scan the QR code, verify our presence using the fingerprint, and the passkey is successfully added. We log out to try using passkeys to log in. We try with Chrome passkey, which uses Google Password Manager behind the scenes. It works. We will log out and try to use the mobile. Scanning the QR code and using the fingerprint for verification, that also works. Final thing is to verify our implementation isn't using the in-memory store anymore. In the database tab, we see that user_passkey table has 2 records, and the user was successfully created under the user table. So we have successfully persisted our passkeys in the database so they can survive application restarts. The only thing pending is that no one wants to use the default Spring Security login page in their production. Most probably you want to integrate passkeys with your existing login Angular application, which was one of the most challenging things to do. So in the next video, we will start integrating passkeys with our Angular application. See you there.